there are 5 important properties of gases. The first one is gases have a variable shape and volume. Gases expands uniformly gases compress uniformly gases has low density. It have a low density and gases mix uniformly with other gases in the same container. So these are 5 properties of gases, and that makes it very special. So when you see it has a variable shape and volume, that means when you have a gas in a container, it takes the shapes of that container, right? When you move from round shaped container to rectangle shaped container, it takes its shape, all right? So, and then yes, its volume also expands. So that's why we say it has a variable shape and volume. Yes, it expands uniformly. Let's say in this room we can keep the gas is in the corner. Do you think we can keep it in a corner? No, it will expand and it will be everywhere, right? Same thing, it compresses uniformly. It has a low density compared to solid and liquid, okay? And it mixes uniformly with others. So those are properties, okay? Basically, the density wise, when you compare, density of air is around 0.001 gram per milliliter. That's for air. And you know that water is what? Water density is 1 gram per milliliter. So you can see it's 1,000 times less than water. You can see this is for air is 0.001 and for water is 1 gram per milliliter. So it's 1,000 times less than water. Okay, and so these are the properties. Now we are going to talk about gas pressure, atmospheric pressure. So let's go to next slide and we'll talk about gas pressure. Gas pressure is the result of constantly moving gas molecules, because it's moving and plus it's striking the inside surface of the container. And that's where gas pressure generates. So what that means, the more often the molecules collide with the side of the container, the sides of the container, the higher the pressure. The higher the temperature. Now how the temperature affects on gas pressure. The higher the temperature, whenever the temperature is high, gas molecules move faster. Alright? So it's the faster movement of, faster the gas molecules move. And if it is faster, then gas pressure what? Increase. It affects on gas pressure. So that's about gas pressure. Okay. Now we will talk about atmospheric pressure and how we measure it. Okay. So let's define about atmospheric pressure. Alright, so first, alright, so atmospheric pressure is the result of the air molecules in the environment. Okay. Now, one scientist invented barometer. So, in a barometer, it was in 1643. So, that scientist's name is Evangelista Torricelli. He invented the barometer. In 1643 to measure atmospheric pressure and whenever the atmospheric pressure, the unit they got atmospheric pressure, they measured in 29.9 inches of mercury or 760 torr at sea level. So now the question is, how that works, because inch or millimeters of mercury, 760 millimeters of mercury, this is the unit of length. How this one works? So I'm going to draw the picture and the barometer, how on what principle it works. Alright, so let's go. I'm going to draw the picture and explain it to you. So what he invented, he took a one kind of bucket or beaker, open beaker, and fill it out mercury. Let's say this is the mercury. Okay, mercury. And then he inserted tube, the open end and close end on the top. It's like inverted test tube on it, glass tube kind of. So this is a glass tube. Now what happened? The atmospheric pressure is pushing on to this mercury, right? This is atmospheric pressure. Same thing here, everywhere. Whenever it happens, the mercury level rises on this glass tube, right? And what that is a measurement of atmospheric pressure. And they measured in 760 millimeters of mercury or 29.9 inches of mercury. I'm going to write the symbol Hg. So barometer works on this principle. It measures in what? Length unit, but it measures the atmospheric pressure. Okay, so now I'm going to write some standard units of pressure. Okay, so I'll go to next one. And unit and standard pressure. For atmosphere, it is 1 atmosphere inches of mercury. If it is inches of mercury, it's 29.9 inches Hg. Centimeters, of mercury, 760 centimeter Hg. Same thing, millimeters. Mercury, 760 millimeters of mercury. Then torr, 760 torr. So you can see these are the units. Pounds per square inch, PSI.
So these are all exchangeable with each other?
Yeah, I'm going to go over some conversion. You get 14.7 PSI and kilopascal. (101 kilopascal). So these are units of pressure, and we'll work on conversion from one unit to other unit. But these are the units for pressure.